the podium. It is my pleasure to introduce David Grimes. David has been Assistant Deputy Minister and Head of Environmental and Climate Change, Canada's Meteorological Service of Canada, since July 2006. He has been Canada's permanent representative to the World Meteorological Organization since December 2006. In 2011, David was elected as president of the WMO and was re-elected by the 17th World Meteorological Congress in 2015 for another 4 years, and he finished his term just last month. He has more than 25 years of experience working with WMO initiatives and programs. With over 45 years of scientific operations, research, and management experience, David's experience includes a significant number of challenging positions and assignments over the years, ranging from weather forecast operations to science policy. David has extensive educational experience in the domains of science and management at the MBA level and holds a Bachelor's of Science degree in physics, mathematics, and meteorology. He has also been trained and carried out the responsibilities as an operational meteorologist. So it is my pleasure to introduce to you David Grimes.
Thank you very much. And just to get started, it's a real pleasure to be here this morning and to share a few perspectives. At least I recognize that 100 years of progress in science has been undertaken, and in part there are enablers in the world, or those who help convene. And one of those organizations is the World Meteorological Organization that has been very much focused, of course, on meteorology, climate, and hydrology. But we've also ventured into a few other areas that link strongly to the work of this particular union, the contribution of the IUGG to the benefits of society. So, I just want to highlight here in this slide that, WMO is more than 100 years old. And interesting enough, John Zillman, who was a president of WMO two sessions prior, so it's about 12 years ago. And this is his quote, that one of the world's most widely used and highly valued public goods. And this is only as a consequence of the benefits of the integration of science for the purposes of informing policy and services. So this will be part of my theme for this talk. So, we've always been involved in a changing world. And, in many respects, on this particular slide, you'll see that, there's been activities at the international agenda, and then you'll see levels. Is that the means I'm finished? This is the Academy Awards, right? Okay, thank you very much. But you can see that in the scientific trends, and this is the reason why I wanted to put this slide up here, you can see that there are clearly some significant benefits that have been undertaken to help set the stage for how science needs to inform meaningfully aspects of society. And you can see, for instance, on this slide, you'll notice some very famous experiments, Thorpex being one of them, and another one more recently, and certainly close to those who have an interest in the cryosphere, such as my host here, the Year of Polar Prediction, which was an initiative to characterize how we could better understand the changes taking place in polar regions, how we could better inform both prediction processes, but also policies that influence that. And the last aspect that I'll mention, because in this very room, well, maybe not this very room, but in this conference center, the the WMO's World Open Science Conference was held a few years ago, where we set a path forward for moving from science that was mostly focused on atmosphere to actually think about earth science. And it's a bit of a theme in my talk. So science policy. So this is an example of some of the WMO's leadership in the science policy domain that I would like to highlight. The first was we ran 3 World Climate Conferences. That led to IPCC, and most of you, everyone here knows how the IPCC has benefited. We also introduced the World Climate Program, and then part of that was the World Climate Research Program. Much of the science supports our understanding of the climate system. And that support, WCRP, is critical to providing the foundation for the assessments being done by IPCC. And also, in this context, the Global Framework for Climate Services, which was in the third World Climate Conference. And that has set the stage for the information transfer from those who know, the science community, how it can be best translated into operational or into knowledge to action pathway so that decisions can be made all around the world. At that time, it was recognized that there was a handful of countries that had the capability of understanding what was going on with our climate system, at least at the stage of our science knowledge at that time. But it wasn't until we've actually initiated this over 10 years, and it was one of my key initiatives as president of WMO to foster this. And now we have 193 members, and there are 150 members now that have basic climate services. And when we started, we had more like 40. So that's an incredible kind of transfer of know-how and knowledge to enable effective actions and decisions all around the world. So, well, actually, I have to make one last point. Some of you know I have championed the cryosphere for WMO over the last 10 years. And we have also, beyond the International Polar Year, was to provide a legacy. And part of that now has moved into the high mountains and recognizing the change of glaciers, of which we have very few monitoring around the world in glaciers. And yet this is critical to understanding the implications of climate change. And so through the introduction of the Global Cryospheric Watch, which is a program similar to the Global Atmospheric Watch, and some of you may be familiar with that, where we're measuring changes in the atmospheric chemistry. This is trying to understand changes in the cryosphere in a way that will provide information about the rate and scale and change that is so important. And that has a very effective engagement from the satellite community. So I have to talk about the importance of science policy. And this is one of the stellar accords that was penned right here in Montreal, 1987. And this was because of our understanding that through our science studies, we could see that there was significant changes taking place in the ozone layer, and the significance the ozone layer has to society. And in particular, we kind of went through this process of informing, taking the science and translating that into the effective knowledge necessary to support that. The beauty of this is probably the only convention that has been completely ratified by all nations. And that's actually in itself remarkable. Even the Paris Agreement hasn't achieved that yet. And the context of the follow-on, which is so important, the work of the science community in framing what do we know and how is the ozone layer changing, And how is it responding to the policies that have been put in place internationally? And you can see from the slides on the graphs on the side that, you know, the ozone is recovering, and we've stabilized most of the chemistry that has been a part of that. The other the other aspect, and just to talk a little bit about the future, because in a sense we've enjoyed this relationship with IUGG over the course of the last century. Going forward, so what do we have in store? Well, you know, it's clear that we're on a path of population growth to be 10 billion by 2050. And we have urbanization and migration to coastal regions. In fact, it's expected that more than half the population of the world will be living in coastal regions, and more than half the megacities in the world will also be in coastal regions. And this is actually quite significant. The population growth is going to put increased demands on our resources, our food, our water, and there'll be demands for scaling up economic activity, which will be kind of driving kind of the energy demands of the world. And this is all in the backdrop of, you know, a changing climate, and we're seeing these escalated risks both in weather, water, and in climate. And we're responding to these kind of new trends with this kind of automation, you know, AI, artificial intelligence, big data. Everyone carries a phone and it's transmitting data all the time. That kind of activity is a bit of a disruptor. And as we kind of move more into an automated world, then the consequences of increasing demands on the kind of information about the environment becomes critically important. And then, you know, it's just been, the Ipsos report was just released about biodiversity loss, and it's significant. And as most of us, well, we're probably a friendly group here where we kind of think we're part of the environment. There are others, humans, that think that the environment is everything that's green, and because we don't have green skin, I guess we're not part of the environment. But reality is we're all part of the same ecosystem. And in that particular context, the implications of climate change are having very significant impacts on biodiversity around the world. And this will become a significant challenge as we look to biodiversity to help us with new medicines and other aspects that are critically important. And so I'm going to skip this slide only because the last four years, and we're on track for this year, as being the warmest, the warmest 4 years in the history of measurement has been since 2015. And we're already on a course for 2019 to be also in that category. So it's clear that when we also look at these trends, we see that there are, if you go back 2 decades, the warmest 20 years has been in the last 22. We've seen the lowest sort of ice extent on both poles. We've seen, you know, it's all happening within this kind of last kind of 2 decades. So for us, this context of where the WMO puts out a state of global climate, and we put this out every year to remind decision makers about the significance of the change, a reminder that these changes are having impacts. And as you can see, even in the news, they're talking about the heat waves in Europe. And if you recall, 2003, there was significant loss of life in Europe. 2009, we had also something similar. Just a couple of years ago, maybe it was last year in Montreal, we also had about 50 people die from these heat waves. And so heat waves is becoming a new risk to society. So, so as we look at the direct and indirect impacts, we start to recognize that our climate is, in a sense, having some controls on our own kind of human behavior. So in 2015, it was a bellwether year for the United Nations, and in particular, this was establishing a 2030 agenda and a coalition, really, of three prominent initiatives. The first one had to do with disaster risk reduction, which was held in Sendai. And this was a call for countries to recognize that there was a very strong relationship between what we're seeing in the context of a changing climate and this context of extremes that are happening more and more regularly, and that we needed to better prepare resilience for society. So it had a strong resilience, build back better theme. The Paris Agreement was a recognition, had two key components of the Paris Agreement. The first was about the importance of adaptation and scaling up capacity around the world. Just check my time. Okay, thank you. So capacity, scale up capacity around the world on how to combat the consequences of a changing climate. And the second, of course, was mitigation, which was recognizing these targets. Last year, the IPCC's report on 1.5 degrees, and I'll come back to that, was that there is no more time, was their key message. No more time. That it's good that we have a conversation, at Paris and the COP about addressing 1.5 degrees. Of course, that was an ambition that was framed in the Paris Agreement, but there is no more time. You have 10 years to kind of get your kind of act together, or we will be into some consequences that will have significant costs and implications to society. And so in this particular context, as we continue to monitor, except for where you could see this this slight downward trend in 2008, and of course you can assign that to the fact that that was when there was kind of worldwide kind of recession, where economies, at least the prominent economies, were suffering. But, we didn't wait too long before we started back up on that trend. And you all recall there was a lot of conversation about this hiatus in the GHG's emissions during this kind of period, and yet we were still seeing this kind of warming. And all of us, from a science perspective, recognize the lag effect that we have with climate change. But we're higher, and we do a summary every year, and we do it based on 2017. It's peer-reviewed, and it's based on strong science. Everything WMO does is based on sort of a peer-reviewed process science. We bring experts together, and they draw up all these conclusions. So these aren't mine. These come from the WMO community, and you can see that in 2017 to the highest they've ever been in 3 million years, and we're still trending up for 2018. And I'll also point out that the early indications, at least for this part of half of this year, it's trending up as well. So nothing's changed in terms of the scaling up of greenhouse gases. So the other aspect, so the World Economic Forum is a group that comes together every year and tries to assess all the grand risks and challenges to international society. And what I like about this slide is that the green dots on this slide are all about environmental drivers. And you could go back at the beginning of 2000, and you would see that most of those green dots were all down in the, were more towards the center and not towards the upper corner. But reality is that the concerns about whether we will deliver on the climate agreement, climate extremes, food scarcity, food and water security, all figure very prominently. This is also a slide that comes out of their, it's an infographic that comes from the same organization. And they're looking at what are the significant drivers of those consequences they see. And if you look in the upper corner, just under rising, you'll see changing climate. And you can see it's having a very broad influence on many other aspects of society. So there's lots of unanswered questions for science in here, in trying to understand how we will feed 10 billion people in 2050, how we're also going to deal with the uneven impacts of our current kind of global warming. And this is an impact of 1 degree based on per capita, which came from the International Monetary Fund, where they were looking at and saying, well, if you look in the southern hemisphere, it doesn't look too pretty. It's there's a lot of consequence. Okay? And then you have lots of potential for where a lot of those countries, particularly in Africa, they're trying to scale up their own economic development. So there are going to be significant challenges with results of that. But you could also look at the question of water stress around the world, this consequence that water, which is primarily being distributed through the water cycle, which you're all very familiar with, is going to disproportionately affect countries. And the ones in red, of course, are the ones that are going to suffer the greatest. And the ones that are in the lightest yellow color are going to suffer the least in terms of water stress. This introduces very significant policy questions to governments around the world about how to deal with water and how water needs to, just in the distribution. And if you add on the fact that the number of people that depend on water are increasing and the activities that follow along with the growth of population, there'll be continued growth. This is actually looking at the aquifers, and this is actually more historical than future looking, and you can see the recharge rates in significant parts of the world. About 1/3 of them are not recharging, and a good deal of the people living in these areas depend on groundwater. And even in Canada, we have a dependency on groundwater. About 30% of the Canadian population depends on groundwater. And at the moment, we have an aquifer that is recharging. But as you look to the future, under water stress, that's actually going to change. And then you look at the insecurity of food, and you can see that this is kind of the present circumstances, climate, and its implication on food security. And as you kind of scale up, you can see the consequences as we kind of look under different type of regimes, and this is more of a business as usual approach. So if no action is taken, there's going to be significant consequences for agriculture around the world. And then loss events, I just remind you that we're still seeing an escalation of these loss events, and 90% of them are now weather related. A decade ago, they were 80%, they're now 90%. And so from WMO's point of view in looking forward is they've kind of reframed their kind of strategy over the next 10 years, which is kind of looking at dealing with this kind of resilience and vulnerability that is being represented. And, framed against, a world where all nations, especially the most vulnerable, are more resilient to the socioeconomic consequences of extreme weather, climate, water, and other environmental events, and those actually relate to air quality. And there's, the WHO just published something recently that said 7 million premature deaths, primarily in Southeast Asia, are impacted by poor air quality. And that's, and there's a capacity as we move into Earth system thinking and Earth system modeling, how we could support that. And then these are all to underpin sustainable development. There's primarily 4 primary areas, but I really only want to focus on science and innovation as being the one that probably be most relevant here. This is where we want to advance our kind of scientific knowledge of the Earth system. And so this is kind of a change for us. We're not actually, we've been very much kind of thinking about atmosphere, ocean, climate. The climate modeling has had to embrace this, but now we're looking at land use change, and the effect of that. And then, you know, if you've been here on Monday, there was a whole session on sustainable development goals. But I only highlight, you can see in blue, there are relationships between what we do as a community, both in the context of WMO convening the power of science, into how we're going to help provide an underpinning and address all 17 of those goals. This one I just have to share with you because this is about water. And one would say water could be kind of a crisis point in society, at least access to freshwater resources. And this is really showing you where you have the direct and indirect impacts as a consequence, and those who are directly related. And you can see that water actually underpins all of those 17 goals in some form or fashion. So science has evolved, so I don't really want to speak, but today most of our modeling centers now have been developing models that you see in that box on the right, or at least my right, maybe it's your left, that says it shows all of the different elements that are now being factored into weather and climate modeling. And the interesting thing is we have 97 members that now operate forecast models around the world. And so this actually is a big trend. There's about 15 that are, I would say, in a high class in terms of have the capability and the resources available to run big, powerful computers and operate good outcomes. But you know, our performance is increasing, and the more we get participation, the more we can sort of catalyze on each other's strengths to make actually better outcomes, to integrate your science. And I'll skip this, but I'll just touch on this and I'll be done. It is just the UN Decade of Ocean Science for Sustainable Development. This is our colleagues in the IOC, which is part of UNESCO, the Intergovernmental Commission on Oceanography. We've been longtime partners. And this, I think, is a critical agenda for the world. It's not, I mean, there are aspects about plastics and other things that are talked about in the terms of the Ocean Decade, but intensifying our understanding of the ocean, where 70% of the planet is probably under-monitored, and this would be a critical opportunity for us going forward to think about how we should be actively engaging in a more integrated way, following some Earth system thinking about how we can take advantage of 10 years of priority that countries will put to this initiative. With this, I will conclude because I'm pretty well done. So thanks very much.
Thank you very much, David. We do have time for a few questions from the audience. Yes, please. If you can access a microphone, please go. Otherwise, please talk loudly.
Thank you so much for your presentation. During your presentation, you mentioned a few times that action needs to be taken, especially with regard to greenhouse gases. Like you said, that there are 10 years to get our act together. Unfortunately, we all know that action is being taken slowly and that there are even some backward steps being made, with the US announcing that they would be withdrawing from the Paris Agreement, for example. My question is, how do you judge the progress that is being made from the scientific perspective? And also, what could we as scientists do differently or do more to contribute to action actually being taken? What would have to change in communication? What can be improved?
So a big question. And what I would try to respond very briefly, but I think this next 10 years for science is a great opportunity for us to kind of become energized, become kind of bring the voice of our understanding to influence policy. We have done this before. That's why I showed you the Montreal Protocol. And it's a working agreement. you know, the difference between political will and science, you know, that's a difficult bridge to cross. I mean, it's to bring those elements together. But there's a couple of aspects that I will share that I think is really important. When I was in Paris, I listened to 150 heads of state. These were heads of state. These were not delegates. These were heads of state. First time ever in the history of the world, they had 150 in one day at one place. Even the United Nations doesn't have them all at the same time. But the reality from that discussion was that the risks and the consequence of how they need to adapt to what they're seeing is onerous. It's huge. So what we need to convey more in this context is the costs associated with adaptation. Because at the moment, I think the political system is very focused on aspects that relate to, you know, what are the economics of this issue and who's all on working in the same direction and that kind of thing. And, you know, governments change frequently, so does the dialogue with governments. You can't say that's just a democratic process for most countries where they elect different officials, bring different priorities. But that for me is, there is a cost to adaptation. There is an impact on how we're going to deal with migrants, for instance, as a consequence of those zones where they can't find food or they can't find water. They're not going to live there. Costs to biodiversity. We need a more kind of an environmental awareness to be framed. Science community is what should be charged up to provide that, because you have the know-how, you have the knowledge. We need to then find the best way to equate or communicate what that science means in the context of well-being of societies around the world. So that's how I'd respond to that. A little bit more emphasis on kind of impacts and the costs of doing that. So it's kind of bringing more social science into our world and thinking about social science as an integrating factor to influence both culture and change.
Thank you, David. I'll take one more question if there is one, because we need to move on. Yes, please.
Thank you. I enjoyed your presentation. I have a question on the impact of climate change on water.
Yes.
Now, I completely agree with you that climate change has a lot of impacts on floods and droughts, and the message that you presented here is correct. But unfortunately, in many parts of the world, direct human impacts on land degradation and poor governance contributes to a lot of water problems. And unfortunately, in many parts of the world, in many countries, governments are hiding behind climate change and not addressing these other issues. And so there's a concept of that I've heard about climatization is a problem. So I think we need a more nuanced presentation about climate change impacts on water issues.
So, I mean, excellent point. I actually listened to your discussion, your presentation on Monday, and in the context that helps me shape kind of the context for your question. In the in reality, water in itself, I mean, climate is just redistributing kind of water resources and our dependencies, but governance and the issues associated with understanding that resource is actually one of the weakest. So I can tell you that, at least as president of WMO for the last 8 years, if I had to pick one data set that seems to be declining compared to everything else that's exchanged in a more open, it's water. And so in that context, at the last Congress, I pushed hard for a critical water agenda for WMO that's going to deal with going beyond climate change. It's going to deal with these issues about land use and land use change, implication of good governance on water systems, and related water quality issues, because they are related. And we are going to hold an extraordinary that we have this, but we had it twice. We had it for the Global Framework for Climate Services. We're going to hold another one in 2021 on water. And for me, this is a great opportunity for us to sort of bring some knowledge forward during this process to help inform the kind of policy discussion that will take place on water in 2021. So it's a great question. Fully agree. Even in this country, governance is a particular aspect because water is a very distributed, I think you call it decentralized kind of responsibility in your talk. So with that, thanks very much.
Thanks again, David.